Visual science experiments that look like magic. Science is often seen as a collection of formulas, theories, and cold hard facts. But beneath that surface lies a world of wonder, one where the laws of physics and chemistry produce results so surprising, they seem to defy logic and venture into the realm of magic. These visually stunning science experiments not only captivate our imaginations but also deepen our understanding of how the universe operates. Whether it's liquids that walk, magnets that levitate, or fire that dances, each of these demonstrations proves that science is far from boring. Let's dive into a world where magic and science become one. Number 15. Non-Newtonian fluid on a speaker. At first glance, it looks like a puddle of goo. But place oobleck, a mixture of cornstarch and water, on a subwoofer. Turn on the music, and watch the magic happen. The fluid begins to bounce, twist, and form alien-like structures in response to sound vibrations. This happens because oobleck is a non-Newtonian fluid. Its viscosity changes under stress. That means it behaves like a solid when force is applied and flows like a liquid when undisturbed. It's a jaw-dropping example of how sound waves interact with physical materials. Number 14. Levitating magnet over superconductors. This experiment looks like something straight out of a sci-fi film. When you cool a superconducting material with liquid nitrogen, it enters a state where it can repel magnetic fields, completely a phenomenon known as the Meissner effect. Place a magnet above it, and it levitates, suspended in midair, without strings or hidden supports. This is not just a cool trick, it's a demonstration of quantum levitation, and it's helping pave the way for technologies like maglev trains and frictionless transport systems. Number 13. Instant freezing water bottle. Imagine opening a bottle of water and watching it turn into ice right before your eyes. That's exactly what happens with supercooled water. When water is cooled below 0 degrees Celsius without being disturbed, it remains liquid. But tap the bottle, and it instantly begins to crystallize into ice. This is a vivid example of how slight disruptions can trigger phase transitions, providing insights into molecular behavior and the physics of temperature. This fascinating phenomenon is often used in science demonstrations to illustrate the delicate balance between states of matter. Supercooled water is highly unstable, and even a small impurity or vibration can cause it to freeze rapidly. It's a clear example of how physical conditions and environmental triggers interact in surprising and visually striking ways. Number 12. Walking on a cornstarch pool. Another fascinating use of non-Newtonian fluids is the classic cornstarch pool. When you fill a tub with a thick mixture of cornstarch and water, you can run across it as if it's solid. But stop moving, and you'll sink right in. This experiment brilliantly showcases how some materials defy traditional definitions of solids and liquids, responding to stress in ways that challenge our everyday understanding of matter. The mixture behaves like a solid under sudden force but flows like a liquid when pressure is applied slowly. This property, called shear thickening, reveals how particle interactions in complex fluids can dramatically change with motion. Number 11. Magnetic putty consuming a magnet. It sounds like science fiction, but magnetic putty infused with tiny iron filings behaves almost like a living creature when placed near a magnet. Over time, it stretches and reaches toward the magnet, eventually engulfing it completely. Filmed in time-lapse, this process is eerily lifelike. Scientifically, it's a mix of viscoelastic behavior and magnetic attraction, illustrating how materials can be engineered to respond to environmental stimuli. The slow movement is due to the putty's high viscosity, allowing it to flow gradually while still maintaining shape. This demonstration highlights the intersection of materials science and magnetism in creating responsive, interactive substances. Number 10. Fireproof balloon with water inside. Normally, a balloon bursts when exposed to a flame, but fill it with water, and it can withstand a surprising amount of heat. That's because water has a high specific heat capacity, meaning it can absorb a lot of thermal energy without a significant temperature increase. The water inside dissipates the heat away from the balloon's surface, preventing it from melting. It's a vivid lesson in thermal physics and heat transfer. This simple experiment visually demonstrates how heat energy moves from hot to cooler areas, protecting the latex from burning. It also serves as a fun and memorable introduction to the concept of energy absorption and distribution in everyday materials. Number 9. Dancing ferrofluid spikes. Ferrofluid is a liquid that reacts dramatically to magnetic fields. It contains tiny magnetic particles suspended in oil, and when exposed to a magnet, it forms sharp, spiky patterns. Move the magnet, and the spikes dance. use alternating magnetic fields, and the fluid pulses and shifts in mesmerizing ways. Ferrofluids are used in advanced technologies like seals and hard drives, but they're also a stunning visual demonstration of magnetic field lines in motion. Number 7. Liquid density rainbow in a cylinder. Layering liquids of different densities can create a striking rainbow in a jar. Each liquid from honey to dish soap to rubbing alcohol settles into layers based on its density. Add a few drops of food coloring to each, and you get a beautiful visual gradient. This simple yet powerful experiment helps students grasp density, buoyancy, and immiscibility in a visually engaging way. Even small objects can float or sink depending on which layer they're placed in, making it great for interactive demonstrations. Number 6. Spinning magnet breaking in a copper pipe. Drop a magnet down a copper pipe, and instead of falling quickly, it drifts slowly, almost as if floating. This is due to Lenz's law. The falling magnet induces an electric current in the copper, which generates a magnetic field that resists the motion. This electromagnetic braking has practical uses in roller coasters and regenerative braking systems in electric vehicles. Number 4. Vacuum expansion of marshmallows. Place a few marshmallows in a vacuum chamber and turn on the pump. As the air pressure decreases, the air trapped inside the marshmallows expands, causing them to swell dramatically. Restore the pressure, and they shrink back. This playful experiment beautifully demonstrates Boyle's law and how gases respond to changes in pressure. Number 3. Sound waves visualized with a Rubens tube. The Rubens tube is an unforgettable way to see sound. It's a metal tube filled with gas and lined with small holes. When sound plays through the tube and the gas is ignited, the flames form wave patterns based on the frequency and amplitude of the sound. It transforms invisible sound waves into dancing flames, a dramatic example of acoustic resonance. Different musical notes create distinct flame shapes, allowing you to visually compare low and high frequencies. This experiment beautifully merges physics, music, and fire to demonstrate the physical nature of sound waves. Number 2. Gyroscopic stability demonstration. A spinning gyroscope resists changes in its orientation, a phenomenon known as gyroscopic stability. This happens because of angular momentum, a principle crucial in designing satellites, drones, and navigation systems. Watching a gyroscope balance on a string or pivot in midair can feel like magic, but it's all due to physics. Number 1. Shattering a wine glass with resonant sound. When a singer or audio device hits the precise resonant frequency of a wine glass, the vibrations amplify until the glass can no longer contain the stress and shatters. It's a dangerous but fascinating demonstration of resonance and the power of frequency. This same principle is considered in architecture to protect buildings from seismic activity. From sound and light to magnetism and motion, these visually arresting experiments remind us that science isn't just something to study, it's something to experience. They offer a unique opportunity to teach complex concepts in a fun and memorable way. What looks like magic at first is actually the universe revealing its secrets to us, one experiment at a time. If these experiments sparked your curiosity, imagine what else is possible when science meets creativity. Try recreating some of these demonstrations at home or in the classroom, with proper safety precautions, and share the magic with friends, family, or students. The more we explore, the more we realize that science is not just about answers, it's about wonder, discovery, and inspiration.